Work out the probability that Debbie takes a strawberry chocolate. Well, if Debbie is picking something from the chocolate box, she's going to end up picking either orange, coffee, caramel or strawberry chocolate. Therefore the probability of her picking something is 1. So these probabilities must add up to 1. So 1 minus 0.15 minus 0.4 minus 0.35 gives you the probability of strawberry, which equals 0.1. Work out the probability that Debbie takes an orange chocolate or a coffee chocolate. So orange or coffee, in probability or means add, so an orange 0.15 plus coffee 0.4, which gives me a total probability of 0.55. Green paint can be made by mixing yellow paint and blue paint in the ratio 2 to 3. So yellow to blue, ratio 2 to 3. So therefore in total, 5 parts, 2 parts yellow, 3 parts blue. If Wendy has made 15 litres, 15 divided by 5 equals 3. So that means that 1 part is 3 litres. Work out how many litres of blue paint Wendy uses, times by 3. So 9 litres of blue, equivalently 6 litres of yellow. Just to check, 6 plus 9, 15. So total 15 litres. Work out the average speed of the plane in kilometres per hour. Well, speed equals distance over time. There's my triangle. Now first of all I need to turn my time into hours. We want, if you look at the solution, kilometres per hour, 9 hours 45 minutes, well, that's 9 3/4 of an hour, 3/4 of an hour, 0.75 is a decimal, so 9.75 hours. So speed equals distance divided by my time, which gives me a solution of 800 kilometers per hour. Describe fully the single transformation that maps shape P onto shape Q. So P onto Q. Well, let's say rotation, anti-clockwise, 90 degrees, about the origin, or the point 0, 0. On the grid, translate shape P by the vector minus 6, 2. Label the new shape R. Well, the top number tells me my movement left or right. Negative left, so I'm moving 6 left. Bottom number, up and down. Positive up, so I'm moving 2 up. So I need to move shape P, 6 left and 2 up. And then label the new shape R. Show that 7/8 minus 5/6 equals 1/24. All the marks for this question are in the method. So first of all, if I'm adding or subtracting fractions, I need to find a common denominator. And in fact, they give me the common denominator in the solution here. Common denominator is going to be 24. We think, what did I multiply the 8 by to get to 24? Well, that's 8 times 3, so therefore I must do the same to the top. 7 times 3, 21. 6 times 4 gives me 24, so then do the same to the top. 5 times 4, 20. 21 minus 20, which equals 1 over 24. Part B. In fraction division, our method is to change the sign to a times and flip the second fraction. Then it's probably easiest to look to see whether we can cancel anything diagonally. 4 goes into 8 twice. 4 goes into 12 3 times. This now makes our multiplication slightly easier. 5 times 3, 15. 2 times 7, 14. 14 goes into 15 once, with a remainder of 1/14. Question 6, solve. Well, when I'm solving an algebraic equation, I need to bring all of the unknown terms onto one side. So first of all, if we take away 2y from the right hand side, and do the same to the left hand side, leaving me with 5y minus 6 equals 8. Now add 6 to the left hand side, therefore I must add 6 to the right hand side. So 5y equals 14. Divide by 5 on the left hand side, therefore divide by 5 on the right hand side. This leaves me with y equals 14 over 5, which equals 2.8. Work out the coordinates of the midpoints of AB. Well, in terms of the midpoint, I'm looking at the difference in the x-coordinates and y-coordinates. So here, I've gone down 2 and along 7. So my midpoint, well, rather than going down 2, must be just down 1. Rather than going along 7, along 3.5. So down 1, along 3.5. Obviously my straight line wasn't very good. So my new midpoint, well, from the point A with coordinates 1, 4, I've gone down 1, making my new y coordinate 3, and I've gone along 3.5, making my new x coordinate 4.5. To work out the length of AB, well, we're told using Pythagoras' theorem. That's the hint. So 2 squared plus 7 squared equals AB squared. 2 squared 4, 7 squared 49, 4 plus 49, 53 equals AB squared. In order to get rid of the square, I now need to square root. So AB equals root 53. Leaving my answer to 3 significant figures gives me the result 7.28 centimeters. Express 204 as the product of its prime factors. Well, 204, it's even, so divisible by 2, which is a prime number. That gives me 102. Again, divisible by 2, a prime number. 51. 51 is divisible by 3, leaving with 17, which is also prime. So 204 equals 2 times 2 times 3 times 17. Alternatively, we can write this down as 2 squared times 3 times 17. Therefore, x is greater than or equal to minus 2 and less than 3. Part B, n is an integer, that means whole number. Write down all the values of n which satisfy this inequality. Well, actually that's the same as the inequality in part A, which we have worked out. The only whole numbers that satisfy this inequality are going to be minus 2, minus 1, 0, 1, 2, and that's it. We cannot include 3, but we can include minus 2 because it is greater than or equal to minus 2, but only less than 3, not equal to 3. The scale on a map is 1 to 25,000. On the map, the distance between two railway stations is 22 centimetres. Work out the real distance between the two railway stations, give your answer in kilometres. Well, if 1 centimetre is 25,000 centimetres, so 1 centimetre on the map, 25,000 centimetres in real life, I want to find out what 22 centimetres is in real life. So 25,000 times 22, which is 550,000 centimetres. So 550,000 centimetres, which is the same as 5,500 meters, which is the same as 5.5 kilometers. 100 centimeters in a meter, 1,000 meters in a kilometer. So final answer, 5.5. You can substitute the x values into the equation to find the equivalent y value, like we have done in part AI. In part AI, we found that when x is 2, y equals 4. So I can sub that in. We could do that again for when x is 5 and for when x is minus 1. Now when subbing in x equals minus 1, you need to be careful. Minus 1 cubed minus 6 times minus 1 squared plus 20 y equals minus 1 times minus 1 times minus 1. That's going to be minus 1. Then I've got minus 6 times, well, minus 1 squared, so that's minus 1 times minus 1. Negative times negative is a positive, so that gives me 1 plus 20. So y equals minus 1 minus 6 plus 20. Y equals 13. Doing the same with the value 5 gives you the solution minus 5. Part B. On the grid, draw the graph of y equals x cubed minus 6x squared plus 20 for the values of x from minus 1 to 6. Well, we have calculated those values, so if you plot the points carefully on the graph and then draw a nice smooth curve through the points. Ooh, slightly off there, but you get the idea. Try and go through every single point, not joining them with a straight line, but a smooth curve. Part C, for the curve with equation y equals x cubed minus 6x squared plus 20, find dy by dx. Now this is what we call the derivative. The process we're doing here is differentiation. If you're unsure in this process, look that up in your textbook or notebook. dy by dx, we bring the power to the front, reduce the power by 1. So bring the power to the front, reduce the power by 1, bring the power to the front. By doing that, we multiply the number at the front by the power, so minus 6 times 2, so minus 12. Reduce the power by 1, 2 minus 1 is 1. If we've got a number by itself, it disappears, so 3x squared minus 12x. Find the gradient of the curve at x equals minus 3. Now, dy over dx is a sort of posh mathematical way of saying gradient. So the gradient at any point on the curve y equals x cubed minus 6x squared plus 20 is given by the equation 3x squared minus 12x. When x is equal to minus 3, we sub that into the equation, and the gradient is going to equal 3 times minus 3 squared minus 12 times minus 3. Now, it's important to remember that a negative squared is positive. Minus 3 times minus 3, negative times negative, positive. Minus 3 times minus 3 is 9, times 3 again, 27. Minus 12 times minus 3, negative times negative, positive. 12 times 3, 36. 27 plus 36 is 63. The table shows information about the amount of money in dollars spent in a shop in one day by 80 people. Work out an estimate for the total amount of money spent in the shop that day. So we want total amount of money spent. Now, the 24 people that are in the group $0 to $20, we don't actually know how much they spent. Some may have spent $1, some may have spent $20, we don't know. We're going to estimate and say that actually those 24 people on average spent $10. The second group, $20 to $40, those 20 people spent on average $30, etc. So we're looking for the midpoint, 50, 70, 90. Now, those 24 people spent $10, so in total, they spent $240. We can do the same for the other groups, so multiplying the midpoint by the frequency. 30 times 20, 600. 50 times 9, 450. 12 times 70, 840. 15 times 90, 1,350. So therefore the total amount spent is the sum of that column, which equals $3,480. So 3,480. As an aside, if I now wanted to work out the mean, well actually we've got the total amount spent. We know that 80 people went in the shop. So if I did 3,480 divided by 80, that would give me the mean amount spent per person. The diagram shows an incomplete regular polygon. Polygon being n-numbered side shape. It's regular, so therefore I know that every angle is the same around the inside, and each exterior angle is the same as well. The size of each interior angle is 140 degrees greater than the size of the exterior angle, so we don't know the size of the exterior angle. But if I call it x, I know that the interior angle is 140 degrees bigger than it. 140 plus x, or x plus 140. Here we've got a straight line, 180 degrees on a straight line. So 140 plus x equals 180. 140 plus 2x equals 180. Take away 140 from both sides, which leaves me with 2x equals 40, and say x must equal 20. So there I have divided by 2 divided by 2. So therefore I know that the exterior angle is 20 degrees, but I need to work out the number of sides of the polygon. Well, now my formula for exterior angle equals 360 degrees divided by the number of sides, and that's one to learn. So if my exterior angle is 20, I don't know the value of the number of sides. Do the old swap and drop method. So therefore n equals 360 over 20, which equals 18. So 18 sides to this regular polygon. So if I'm looking for the largest surface area, okay, don't be fooled by the values at the front, so these ones here. Okay. The times 10 to the power of bit tells me the size. So the Pacific I could write as 15.6 times 10 to the power of 7. Now you'd all agree with me that actually the Pacific is the largest ocean, not the Atlantic. So the Pacific is the largest ocean. To work out the total surface area in kilometers squared of all 5 oceans, giving your answer in standard form, I need to sum the columns. So 7.68 times 10 to the 7 plus 6.86 times 10 to the 7 plus 1.56 times 10 to the 8. You can do this on your calculator and it will give you the value 3.358 times 10 to the power of 8. Part C. The total surface area of the Earth is 5.1 times 10 to the 8 kilometers squared. Express the total surface area of the 5 oceans as a percentage of the total surface area of the Earth. Well, the total surface area of the 5 oceans is 3.358 times 10 to the 8. That surface area out of, well, the total surface area of the Earth is 5.1 times 10 to the 8. This would leave my answer as a decimal. To turn it into a percentage, I times by 100. This gives me the solution, 65.8431, etc. Leave your answer to one decimal place, say 65.8%. Peter and John play 2 games of badminton against each other. For each game, the probability that Peter wins is 0.15. Complete the probability tree diagram. Well, Peter wins 0.15. If they're playing a game of badminton, either Peter wins or does not win. So therefore, the probability he does not win, 1 minus 0.15, which leaves me with 0.85. The second game, again, Peter can either win or not win. Win, not win. Again, the probabilities are still the same. 0.15, 0.85, 0.15, 0.85. Part B. Calculate the probability that Peter wins both games. So he wins and wins, i.e. wins the first and wins the second. In probability, and means multiply, or means plus. So to win the first game, 0.15, and win the second game, 0.15 times 0.15, which leaves me with the solution, 0.0225. The pressure P of water leaving a cylindrical pipe is inversely proportional to the square of the radius r of the pipe, and it's the square of the radius r of the pipe. So P is inversely proportional, so 1 over, and it's the square of the radius. So P is inversely proportional to r squared, or alternatively, P equals K over r squared. Now we want a formula for P in terms of r, i.e. we need to get rid of this K value, but we know 2 points that we can sub in. So when P equals 22.5, r equals 2. 22.5 equals K over 2 squared. 2 squared is 4. To get rid of the divide by 4, times by 4. I've done that to one side, I must do it to the other side. 22.5 times 4 gives me a value of K equaling 90. So therefore the formula is not K equals 90, but P, the pressure, equals 90 over r squared. That's the formula for P in terms of r. We can now use this formula in parts B and C to work out the values in part B of P and in part C of r. So using the formula, P equals 90 over r squared. Calculate the value of P when r is 1.5, so P equals 90 over 1.5 squared, which gives me the solution. Part C, again using the same formula. Calculate the value of r when P is 10. Using the swap and drop method, r squared equals 90 over 10. So r squared equals 90 divided by 10 is going to give me 9. R equals the square root of 9. Now square rooting something gives me two values, plus and minus 3. However, in the context of this question, we're looking for the radius. That's a length. A length cannot have a negative number. So the radius of the cylinder must be 3. Positive 3, not negative 3. I think a nice way to think about functions is to think of it as a machine. I have an input. I put it through my function, and I get an output. So my input, 17a, I input the value 8. And the question is asking, what is the output? So inputting 8 into my function, 8 minus 6 all over 2, so I'm substituting where I see an x with the value 8. 8 minus 6 is 2, 2 divided by 2 gives me the number 1. Express the inverse function in the form f minus 1 of x. Now the inverse function is what takes me from my output back to my input. Okay, so that's the inverse function. How do I get from my output back to my input? The way to work this out is, rather than writing f of x equals x minus 6 over 2, write it as y equals. Then just swap where you see an x, write a y, and where you see a y, write an x. Now we want to rearrange it into the form y equals again. So first things first, times by 2. 2x equals y minus 6. Add 6, leaving me with 2x plus 6 equals y. Final step, I replace the y, so rather than writing the y, I write f minus 1 x equals 2x plus 6. So f minus 1 of x, 2x plus 6. Which values of x cannot be included in a domain of G? Domain, another word for input, so which input values cannot be included. Now, we know that we cannot square root a negative number, so therefore x minus 4 must be greater than or equal to 0. If it's less than 0, it's negative. So x minus 4 must be greater than or equal to 0. Solving that, x must be greater than or equal to 4. I did that by adding 4 to each side. So if they're the solutions that x can take, therefore x cannot be less than 4. Express the function gf in the form gf of x. Well, gf of x, to work out what that function is, what I'm going to do is replace where I see an x in the function square root x minus 4, I'm going to replace it with the function for f of x. So I'm going to square root f of x, because I'm replacing x with f of x, minus 4. We know that f of x is x minus 6 over 2, so I'm going to square root of x minus 6 all over 2 minus 4. And we need to express this as simply as possible. So therefore, simplifying under the square root sign, by combining the fractions, 4 is the same as 8 over 2. So therefore, I've got the square root of x minus 6 minus 8 all over 2 minus 6 minus 8. Well, that is minus 14 all over 2. So gf of x is the square root of x minus 14 all over 2. Now in a histogram, frequency is proportional to the area. So if I want to calculate an estimate for the frequency, I need to work out the area between 4.5 hours and 8 hours. So between 4.5 and 8 hours. So working out the area of each bar, well, I've got this first bar, which obviously has width 0.5, height 160. The second bar has a width of 2 and a height of 50. And the third bar here has a width of 1 and height of 25. So I've got 0.5 times 160, which is 80, 2 times 50, which is 100, and 1 times 25, which is 25. The sum of those, which gives me 205, is an estimate for the number of cars that were parked for between 4.5 hours and 8 hours. Write down the length QT, well, the length of QT is 6 centimeters, and my reason for that is that tangents to a circle meeting at a point are equal in length. Part B, the perimeter of triangle PQR is 42 centimeters. Calculate the size of angle PQR. Well, we've already said the length QT is 6, equally by the same reasoning, the length PQ is 7. Now we don't know the lengths UR or TR, but we do know that they're the same length. Equally, we know the perimeter is 42. So therefore the distance all the way around the edge must be 42, i.e. 6 plus x plus x plus 7 plus 7 plus 6 must equal 42. So simplifying the left hand side, 6 plus 7 plus 7 plus 6 is going to equal 26. X plus x, 2x equals 42. Take away 26 from both sides. Which leaves me with 2x equals 16, and so x equals 8. So now we know that these lengths here are both 8 centimetres. Now in order to calculate the angle PQR, if I redraw the triangle and actually calculate the total lengths of each side, so length PQ, which gives me 13, length PR, which is going to give me 15, and length QR, which equals 14. I can then use the cosine rule to work out this angle. Now the cosine rule, as expressed on the formula sheet, is a squared equals b squared plus c squared minus 2bc cosine a. A rearrangement of that to find the angle A, if I move the 2bc cos a to the other side, so add it to the other side, minus the a squared, and then divide by the 2bc, give me cos a equals b squared plus c squared minus a squared, all divided by 2bc, I can then use that to work out the angle A. Now if I label on the diagram the corner at which I want to find the angle, corner A, I don't know about the other two, so call those A and B and C. Labelling the opposite sides with the little letter, so opposite capital A, little v, little t. I can substitute these values into the equation and hence find the angle. So substituting into the formula, 13 squared plus 14 squared minus 15 squared divided by 2 times 13 times 14, and then inversing cosine, so moving the cosine to the other side by inversing it. Inverse of 13 squared plus 14 squared minus 15 squared divided by 2 times 13 times 14 gives you the value A equals 67.4 degrees to 1 decimal place, i.e. angle PQR 67.4 degrees. So in question 20, part 1, finds n, which means the number of members, so the number of members in the set A or B, alternatively said as A union B. Now, in our Venn diagram, the numbers in the Venn diagram represent the number of elements. So we have 6 elements in A. 2 plus 4 is 6. And in B we have 9 elements. So in A or B we have 9 plus 6, 15 elements in total. Part 2, the number not in B, so B dash means not in B. Well, not in B, we've got 7 in C that's not in B, plus the 4 that are in both A and C, plus 2, plus also the 10 on the outside, which gives me a total of 23. Part 3, so the number in A and not in C, so it must be in A, but not in C, so it only includes a crescent sort of circle, therefore just 2 members in that set. Part 4, the number not in B and not in C. So if we're not in B and not in C, then we must either be in this crescent moon bit here of A or on the outside. So the number not in B and not in C are 10 plus 2, which is 12. So not in B, and alternatively that sign can be read as intersect. So not in B, intersect, not in C, not in B, and not in C. 2 plus 10, which equals 12. PQRS and PSTU are parallelograms. We're told that the vector P to U is A, P to S is B, P to Q is C. Remember, direction is important. As they're parallelograms, therefore, we know that Q to R must also be P. It's parallel in the same direction, and parallelograms have opposite sides equal in length. Equally, u to t, by the same logic, must also be p. S to t and S to R, C. So to go from T to Q, the route I'm going to take, well, you can take many different routes, they'll all give you the same vector outcome. I'm going to go T to U, T to P, P to Q. So I get minus P, so I'm going the opposite direction to the arrow. So minus P, minus A, plus C. Part 2. Find in terms of A, B and C the vector P to X, where X is the midpoint of T to Q. So if I draw the line T to Q, X is the midpoint. So on some point on this line, let's say there. Now in order to work out the vector P to X, the route I'm going to take this time is starting at P, I'm going to go to U, to T, and to X. P to U, we know, is A. U to T, that is B. Well, T to X, that is the midpoint, so X is the midpoint of T to Q. We know that T to Q is minus B minus A plus C. As X is the midpoint, I'm adding on half of minus B minus A plus C. Simplifying this, well actually half of minus B minus A plus C is the same as half of B minus half of A plus half of C. And so I've got A minus A over 2. So A minus half A, which leaves me with half A. B, take away half B, which just leaves me with half B. And finally, half C. This can be further simplified to A plus B plus C all over 2. Question 22. Calculate the size of the angle between TB and the base ABCD. So there's the line TB and the base. We'll just work out the angle between it. We have to think about the points directly below T on the plane ABCD. That's the point M. So that gives me my triangle. I need to work out the angle at this point here, which I'm going to call theta. Redrawing this triangle, which might make it easier to see what's going on. There's my angle theta, M, T, B. I know the height Tm is 6. I need to work out this length MB so that I can use trigonometry to work out the angle theta. To work out the length MB, I need to use the triangle AMB. The length AB I know is 10. The length MA, well, D to A is the same as B to C, so 7. M is the midpoint, so A to M is 3.5. Using Pythagoras, well, MB squared equals 3.5 squared plus 10 squared. So therefore MB equals the square root of that. So the length MB, square root 3.5 squared plus 10 squared. I can now use trigonometry on this triangle to work out the angle theta. The length opposite the angle, the length 6. The longest length, TB, is h, our hypotenuse. Length MB must therefore be the adjacent. I know the adjacent and the opposite. The formula that links opposite and adjacent is TOA. If I want to work out the angle, tan theta equals opposite divided by adjacent. 6 divided by square root of 3.5 squared plus 10 squared. To work out the angle, I inverse tan, so shift tan on the calculator, the result I got before, so inverse tan this part, giving me a value theta of 29.5 degrees to 1 decimal place. In order to solve this algebraic equation, I think probably the easiest way you can do this, there are a number of ways, is to first cancel out some of the denominators. So if I times this term by 2x minus 3, hence cancelling out the denominator, if I times that term by 2x minus 3, I must do the same with all the others. And to cancel out the other denominator, if I times this term by x plus 1, therefore I must times every term by x plus 1, I end up with the result 3 times 2x minus 3 plus 2 times x plus 1 equals one lot of those two brackets, or just 2x minus 3 x plus 1. Simplifying the left hand side, I've got 3 times 2x, so 6x minus 9 plus 2x plus 2 equals the right hand side 2x squared plus 2x minus 3x minus 3. Simplifying the left hand side, 6x plus 2x, 8x minus 9 plus 2 minus 7 equals 2x squared, 2x minus 3x minus x minus 3. Now to solve this, I need to bring everything onto the right hand side. So adding 7, taking away 8x, and so doing that on the right hand side as well. Taking away x, 8x, adding 7, taking 8x and adding 7 to the left hand side leaves me with nothing. 2x squared minus x minus 8x minus 9x minus 3 plus 7 plus 4. At this point we're looking to get x equals, and it's a quadratic, so we're going to need to solve. You can either use your calculator or the quadratic formula or factorize, which is what I'm going to do. So factorizing into double brackets, I'm looking for values that multiply to make 4, and then when expanded the numbers sum to make minus 9. The only way that can be done is if I have minus 4 here, minus 1 there. The reason being, minus 1 times minus 4 is plus 4. 2x times the minus 4 would give me minus 8x. Minus 1 times the x gives me minus x, so I've got minus 8x minus x, which gives me my minus 9x. And so therefore solving, well, either this bracket must equal 0 or this bracket. So either 2x minus 1 equals 0, in which case add 1 to both sides, divide by 2, x equals a half, one value, or x minus 4 equals 0, add 4 to both sides, so x equals 4. So my solutions are x equals a half and 4.